So I used to study biology, life science. But then I was like, nah. So I dabbled in a couple different things until I finally landed on programming. That was pretty cool. So I decided to end up going to a coding boot camp, which chewed me up and spit me out about 3 months later. So I wanted my first personal project to somehow combine...
We're gonna combine!
We're gonna combine?
They're gonna combine! They're gonna combine!
both biology and programming. So I thought of the perfect project to make. The game of life in 3D. If you don't know what it is, it's a specific rule set for cellular automata, which is basically a theoretical simulation of how cells could be autonomous and perform complex tasks without explicit instruction. Whatever that means. So the rules of the game are as follows. Any live cell with fewer than 2 live neighbors dies as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies as if by overpopulation, and any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. So, TLDR, the cells live or die based on the cells around it. Seems simple enough, right? Well, the guy who invented this rule set, his name is Conway. He was a brilliant mathematician, he was active in a bunch of different theories, including knot theory, number theory, and coding theory. Or so I've been told by his wiki. Now, unfortunately, he passed away this year due to the thing that must not be named on YouTube. However, I thought not only would this, project connect my past and present, but it would also serve as an homage to Conway and his life. So with introductions out of the way, I'd like to show you my project. You open the app and you press play. On the left is a classic game of life. Using the rule set, each cell updates to the next generation 10 times a second. And that's cool. But on the right is the game of life in 3D. Oh, what's that? You want a better view? Boom! Camera controls, baby! As you'll notice, I create the 3D view by stacking generations on top of each other, where the topmost layer is the most recent generation shown by the 2-dimensional view, and the bottommost layer is the oldest generation that's rendered. Now that is even cooler. Huh? You want to pause the game? Well, you can. Huh? You want to clear the grid? Well, you can. Huh? You want to randomize it again? You can do whatever you want. If you want to be a little fancy, you can even place and remove cells of your choosing and make cool configurations like these gliders, which glide across the grid. So one thing you'll see when the gliders move to the edges of the grid is that they end up on the other side. And this is because I use something called a toroidal array, which basically in this case just means that the left bounds are connected to the right bounds and the upper bounds are connected to the lower bounds. So visually, Conway's game of life on a toroidal array could look something like this. Well, now that you've seen the project, let's talk tech. I use 3 main technologies to create this project. The first is React, which is a JavaScript framework for single-page applications. I used this for the 2D visualization because it allowed me to manipulate the DOM, or whatever a user sees, very quickly without having to reload the page every time the data or state changed. I also used Three.js, which is a JavaScript library / API used to display 3D graphics in a web browser using WebGL. Now I use this for 3D visualization because it allowed me to very easily render 3D models within the browser without any proprietary plugins, all while using JavaScript. Now the third technology that I used is Redux, which is a JavaScript library for state management commonly used alongside React. Now the reason I use this is not so apparent, and this is because I haven't implemented multiple components within the application. But were I to add more components for the user to toggle between, it would essentially allow me to store my data beyond the
Even further beyond!
life cycle of the components. Now all this talk about data, but what is it and where is it going within the application? At its core, the data I use are simply zeros and ones, where 0 represents a dead cell and 1 represents a live cell. And then I store these values into an array, which corresponds to a row within a 2-dimensional grid. And I store those arrays in another array, which corresponds to the entire 2-dimensional grid, and represents a generation. And I store those arrays into another final array, which corresponds to the 3D grid and represents stacked generations, making this sort of three-dimensional array. And what's cool about this is you can actually access each individual cell in this sort of nested array using a coordinate system, where the indices actually correspond to the height, the width, and the length of the three-dimensional grid. And that's it! Boom bada bing, project done. Hey, you.
Hey, you.
I just want to let you know that I really appreciate you sticking around to the end of the video since this is my first YouTube video. Now before you go, maybe you can flip a coin. If it's heads, like the video. If it's tails, like the video. Comment down below and let me know what you thought of the project or the video, so I can make improvements in the future. And honestly, thanks for watching.